So again, thank you and welcome, and I'm really excited to be back in Athens and present this topic to you, improving building performance. This topic that several of us are in the room here are ASHRAE distinguished lecturers, and this particular topic is one of the DL talks that I do. And at the beginning of every DL talk, there's a little bit of ASHRAE promo here. So I don't think you're going to have it's not the DL, but this is important. How many of you are ASHRAE members? Not many, only a few. You need to join the family. You need to join ASHRAE's family and volunteer. All right. This topic, hopefully, when you leave here, you will know a little more than you did. There are some learning objectives here. The first one is to understand all of the characteristics of building performance, and then identify the tools that you can use to improve that performance. Understand the procedures that may be necessary, and then learn how to analyze the data so that you can really make it work. That's the most important part. So what is a high-performing building? There are a lot of definitions floating around. Those of you that do this for a living, and most of you do, otherwise you wouldn't be sitting here. You've seen lots of things written about what are now known in the industry as high-performing buildings. This is the best definition I have ever seen. And I'm standing in your way so you can't see the screen. A building that is energy efficient and healthy and comfortable for its occupants. Now think about that. It's really simple, but it's really important. And this is, again, this is of all the definitions of high-performing buildings that I have seen, this is really the best one. So what are the components of a high-performing building? What are the parts and pieces that make a building perform? And if we were going to improve those things, what are the things that we need to look at to improve? Anybody got an idea? Well, the topic of this whole conference today is energy in buildings. So guess what the number one component of a high-performing building is? But they're not the only components of a high-performing building. We will focus this talk here for the next few minutes on energy because that's the topic of today's conference. But I would really be remiss if we didn't at least cover briefly the other components of a building that is performing where it ought to perform. One is water. We'll talk about that in a few more minutes. One is the indoor environment. And the last one might be the most important. People productivity. I keep standing in the way of this. Just trying to see the screen, I'm sorry. I mean, if you're not productive in your building, why even have the thing? You know, that's what it's all about. This might be the most important of the four. And we can talk about how to get there. Now again, today's conference is all about energy in buildings. And so we're going to focus on that, which means I'm going to save it to last. Let me talk a little bit about these other three really quick, because they are extremely important when you're talking about a total building. First one is water conservation. Pretty funny picture. Got a no swimming sign in front of a desert. But that's actually not a really funny situation. It's pretty sad. This actually used to be a lake in California in the United States. And that part of our country in the U.S. is in a severe drought and has been now for 10 years or more. And that lake is all dried up. The Colorado River that runs through a good bit of western United States doesn't even get to the ocean anymore. It's dried up and runs out. And it's all because of weather conditions, yes, but we could make it better through water conservation. And how do you do that? Especially in a building, how do you do that? Well, the first thing you got to know is what water is being consumed. And in a domestic building, you have your hot and cold water at your sink, you have cooling towers, you have boilers, and you may have processes going on that use water. So, how can you conserve that water? First thing you have to do is know how much water things are really using, and it may be that you're going to have to sub-meter some of those conditions. That's actually very popular in the U.S. I don't know if it is here, but that's a pretty popular thing. And then you can supplement your water supply, rainwater collection and rainwater for irrigation and rainwater for waste, flushing the toilets and things like that is becoming a really popular notion. I mean, the water's coming down from the sky. Why not use it? Okay? So let's talk about the third one of our parameters from a little while ago. Indoor environment, and there are actually some components to the indoor environment. One is thermal comfort. Do you think this guy is really comfortable? He's freezing to death. How many of you sit in an office where you're freezing to death? It's not uncommon. Thermal comfort. ASHRAE has a standard for that. ASHRAE standard 55 is the comfort standard. And there are lots of charts and lots of procedures and all about, what kind of clothes to wear and all that. But this is actually code in some areas. ASHRAE standard 65 is now a code in some areas, building code. The two things that you can control probably in your space are temperature and humidity. But how do you know whether this guy is really comfortable or not? You need to survey your occupants. Some of you may be familiar with the U.S. Green Building Council's LEED program. Part of the LEED program is follow-up, a lot of follow-up, and you are required to go to your building occupants and find out if they're happy people, and if they're not, you're not meeting the standard. Indoor air quality. How many of you work in an office like that? You think that's good indoor air quality? That's an old picture. That's back when you used to could smoke in your office and all that stuff. Some places you can still do that. But indoor air quality is extremely important in a building environment. Things you can look at are outside air and ventilation, monitoring the CO2. That room right there would probably go off the charts. And there are other contaminants in a room from construction, from building materials, carpets, paint, drapes, things that can contribute to really poor indoor air quality. The Another component of the indoor environment is lighting. That room is lit up pretty good. Do you think that's very efficient? Probably not. Does it even need to be lit like that? Probably not. There are standards that you should follow. The Illuminating Engineering Society, IES, is one of ASHRAE's partners. They've written several standards with us. But there are others, especially here in Europe. LED is now the norm, and that's a great thing. At least in the U.S., LED lighting is pretty typical on all new projects and a lot of retrofitted projects. And those of us that are design engineers, it has allowed us to take a whole lot smaller chunk of our HVAC load due to lighting. Typically, this is a third of what it used to be. So always be sure you're headed that way. And then once you get the lights on, efficient lights installed, you don't need to leave them on all the time. How many people are in that office right there? None. And the lights are on. Is that very efficient? Probably not. How many windows do you see in that room right there? Not all one. And daylighting can be extremely helpful in reducing your lighting load. So here's another component of indoor environment. By the way, that's an engineering office. It's an old picture. How many of you, like me, grew up in an office like that? Let's see. It's almost getting old. That's what that means. The other part of indoor environment is acoustics. And again, you need to know if your people are happy or not. If they are in an environment like that, they're probably not happy. They can hear everything that's going on. And so you need to measure the sound. And then this is what it's all about. Studies show that the productivity of your workers in your offices can be increased by as much as 15% by paying attention to the items that we just talked about. And there are a number of studies. Riva here in Europe produced a few years ago a lot of research and studies about this. Where does all that come from? Well, here's some examples. If you decrease the temperature in your room by just a few degrees, you can get as much as a 6% increase in productivity. That's pretty important. And interestingly enough, the research shows that if you start raising the temperature in the room, people go to sleep or something. The productivity really falls down. But you can decrease the temperature 3 degrees. If you increase in ventilation and improve the indoor air quality, you could raise your productivity by as much as 7%. Lighting upgrades and lighting control and the day lighting and all those things we talked about a minute ago could net you maybe a 3% improvement. And this is really amazing. If you cut out the noise in an office environment, the productivity jumps almost as much as 9%. There are studies that show as much as 9%. And that's amazing. Just control the noise in your office. Okay. I told you we'd skim through the other parameters and focus on energy here for a few minutes. And why do we need to do that? This is from the United States. This is the U.S. Department of Energy. Every few years, they publish data about energy consumption, and they break it down, and we'll talk about that in just a minute. But this is straight from the U.S. Department of Energy for last year, for 2016. Now it's kind of interesting, and I know the other half of this conference today is about energy and transportation. And at least in the United States, all of the press and all of the news you hear and all of the marketing that you hear is all about mileage in a car and saving energy while in your car. We're going from 20 miles a gallon to 28 miles a gallon, and that's the big focus. Well, guess what? Only 29% of all the total energy in the United States, if you added up all the cars and the buses and the planes and the trains, they only get about 30%. Okay? The biggest culprit is buildings. That's why this is really important. And again, this is a graph from the United States, but it's probably typical all over the world. Buildings are the #1 consumer of energy, just about everywhere. And it's about half and half residential buildings and commercial buildings in the United States. I suspect that percentage is going to change a little bit depending on where you go around the world. But no matter where you go, buildings are going to be the #1 consumer of energy. And that's why it's important for us to focus on that. And it's really interesting that it doesn't get a lot of press. It doesn't get a lot of news coverage. And if you decrease your building consumption 30%, you're not going to get a front page article like you would if you decreased the mileage in your car. It's just kind of misplaced. But see, we're all in the industry, we can say that. When you're talking about reducing building energy, there are really 2 goals that we want to focus on. Okay? One is eliminating the waste. Remember that picture of the office and the light? Good Lord. How wasteful is that? It's overlit. The lights are on when nobody's there. I mean, that's just terrible, wasteful energy. So we want to concentrate, and one of our goals is to try to eliminate the waste in your building. And the second goal is to improve system efficiency. Now, the key word in that sentence is system. You can go buy the most efficient new air conditioner and the most efficient new motors and new fans, but if they don't work together, you're still wasting energy. You have to approach this by looking at your total system, and you achieve energy reduction by improving system operations, not just putting in new, going from a SEER 5 to a SEER 10 piece of equipment, that's a good thing to do, but is it really helping? You have to approach this from a system perspective. So how do we do that? If you don't learn anything else today, write this down. You cannot manage what you cannot measure. Somebody told me a long time ago, if you don't know where you're going, you're never going to ever know if you got there. Okay? Same thing. You have to know what you want to achieve, and you have to know how badly things are right now in order for you to set your goals and meet those two objectives we just talked about. You cannot manage what you cannot measure. So the first step, remember one of our learning objectives today is to learn the steps. The first step is to measure what you got and find out exactly what your existing conditions are. Now there's a lot of ways to do that. And there's a lot of debate about what to look for, and you know, it's beyond the scope of this thing here today to get into those debates. My comment about all that, having done this for a long time, is that they're all good. I mean, they're all trying to achieve things. But you need to kind of settle on units that you can use to see if you have achieved your goals. And typically that means units of comparison. So in the world of energy, and I don't care where you are, in what part of the world, the unit that people typically look at is the EUI. Everybody heard of this before? This is not news, okay? Energy use intensity. How much energy are you using per a defined space per year? Energy use intensity. You know, in the IP world in the U.S., it's thousands of BTUs per square foot. The SI equivalent of that is kilowatt hours per square meter. But again, it's a method of comparison. The U.S. Department of Energy has a program called CBEX. Everybody in our industry in North America, this is one of the first things you start to look at. How many of you have ever heard of CBEX? And I'm sure you have some equivalent here. It's the Commercial Building Energy Consumption Survey. They don't do it all the time, which is really kind of a shame. They did it in about every 2-3 years until 2003, and then the U.S. government went through a cost cutting, and CBEX was one of the first things they cut. And so we didn't get good CBEX data for a long time. They restarted the program in 2012, and they did another complete survey in 2012, and then it took them a couple of years to compile the data. And so, and the data is, I mean, you can go online to U.S. Department of Energy, CBEX, and there are about 24 Excel files and PDF files you can, and you will be awake for the next 2 weeks reading all this data. It's a huge amount of data. And I just grabbed one of them that is pretty typical and one we use a lot for office buildings. And I'm talking about every commercial office building in the United States. The average is 77 1,000 BTUs per square foot per year. And if you do the conversion, that's like 245,000 kilowatt hours per square meter per year. I've given presentations to other organizations, Rotary clubs and things like that, about what I do, and I talk about this, and people have a hard time getting their understanding this and getting their arms around it. Right here is 1 square foot of space, and that 1 square foot of space used 77,000 BTUs this year. And everybody goes, wow. And they should, because that's a lot. 245,000 kilowatt hours per square meter. That's a lot. Okay? We get the hook over here. So what do we do about it? Well, here's some of the tools that we want to use. How many have ever seen this book? A few people. Oh, more people than I thought. Good. This is an ASHRAE publication. It's called The Procedures for Commercial Building Energy Audits. And in this book, there is a description of procedures for 3 different levels of energy audits, or what we now like to say is energy assessment. Okay? There, at a minimum, when you are starting to identify and measure what you are looking at, you should do what this book describes as a level 1 audit, which is reviewing the utility bills, analyzing the building operation, and actually getting out and doing the building. I can't tell you how many people are in our business that try to model a building and they look at energy bills and they look at plans, but they never go out and see the building. You got to go out and see what's going on. And then you can identify potential low-cost upgrades. Here's another tool, and I emphasize the word tool. How many of you have ever heard of building EQ, ASHRAE's BEQ program? I have a whole another DL lecture on this that could go on for another hour. The Building Energy Quotient was started as ASHRAE's labeling program. It actually was modeled after the labeling program that you have here in the European Union. I was on the original committee. I was actually chair of the committee, and we had representation from people from all over the world. It was a labeling program. You get, based on your consumption in your building, you get an A, B, C, D. Just like you do a lot of buildings here in the EU. Okay. But BEQ has evolved, and in fact, this past year, there's been a lot of changes in the Building Energy Quotient program, and guess what? It is a fabulous tool for measuring what's going on in your building, and that's what I see the advantage of this program is. So I would encourage you to learn more about it. So once you know about what's in your building, how do you begin to figure out how to improve things? Well, the first thing you got to do is comply with standards. I've thrown 2 of them up here. 90.1 is ASHRAE's flagship standard. It's energy consumption in new buildings. And standard 100 is not nearly as known, but it's energy consumption in existing buildings and what you can do to improve that. Okay? And I heard somebody comment a minute ago in one of the introductory speeches You know, the truth is in Europe, most of the buildings are existing. So something like standard 100 would apply. Start with the low-hanging fruit. I could, I'm getting the hook over here, but I could give you a lot of case studies. We did a training session at, I think it was Milwaukee, for students that were wanting to learn the commercial energy audit things. And the people at Milwaukee said, well, we've already done surveys of our buildings, you're not going to find anything. We turned the students, it was a 3-day seminar, we turned the students loose on the second day. They came back with 42 new ways to save energy, and every one of them was significant, and every one of them didn't cost Milwaukee a thing. It's all low-hanging fruit, okay? You just got to know what to look for. And the other part of this is modeling. Energy modeling is becoming much more important, and as you're looking to, you know, again, I'm getting old. When I started this, nobody ever heard of modeling. Now you don't do a project without modeling, and it's really important as you're picking the right kinds of things to improve your building. What about renewables? Again, I could talk about this for a long time. Zero energy buildings, there's some other presentations this afternoon as the day goes on. I saw some that are going to focus on this. So I'll go through this real quick. There is a danger in relying on renewables, because you forget about conservation. If you have the ability to set up, and you don't always have this ability, but if you have the ability to set up a renewable energy source, you may decide, okay, I got lots of energy and now I can just get it free. And you forget about conservation. This poor fella in this hut here, he added up the 5 watts he needed in that hut and threw a solar panel on the roof. This is a funny example, but I've seen this happen. If you have the room to do this, I have seen people forget about conservation and just make it all up, and there's zero energy, okay? You don't really want to do that. My good friend Kent Peterson, who was an ASHRAE president a few years ago, this came right out of his presidential theme speech. And I've always had this in this slide, in this presentation. That's the holy grail. If you can combine conservation with renewable energy generation, that's a zero energy building. That's the holy grail. And the last thing I'll say about that, as it relates to this topic this morning, is people always assume that you have to be doing this in a new building. You don't. You really don't. Building renovations are a big part, and you can do that by just following these 4 steps here. And the one I want to highlight is plug loads. Oh my gosh. The plug load these days is unbelievable. Everybody's got computers and printers and new machines and video games. Okay. Those are some of the tools. So those are some of the steps. I'm going to go through this in like 30 seconds and then I'm done. There are some other resources out there. A lot of what I just had up here on the screen came out of these 2 books. These are 2 ASHRAE publications, and if you go to the bookstore, they look almost the same. This is the original document. This is Performance Measurement Protocols for Commercial Buildings. This is kind of a very academic. There were lots of, this is the committee that put this together did a great job of putting together all of the different ways you can measure things in a building. And it's a great book. It's a great source of information. It's also very, very, very academic. And so a couple years after this was published, they have published, another committee put together how you use that information in a best practices guide. And if you go to the bookstore, the book will look exactly like this, except down here it says best practices guide. Those are great sources of information as you begin to tackle this kind of project. How many of you have ever heard of 189? Okay, 189 is quickly becoming ASHRAE's new flagship standard. It's the green building standard. And the news about 189, although this has slowed down a lot, this all happened the year I was president, and we're a little off schedule now for lots and lots of reasons. But 189 and the International Code Council's IGCC book are scheduled to be combined into one publication, which is great news because it eliminates a lot of confusion about which one do I use, and da-da-da-da. Again, for politics and other reasons, the schedule's slowed down a little bit, so I may actually have it up here. But and then in the residential world, how many of you are in the residential world? Some of you. In the U.S., we have Standard 700, which was originally developed by the American Home Builders Association. ASHRAE is now a part of that publication and is a major contributor. And that's the national green standard for residential buildings. And lastly, I want to talk about this. We've completed this project and the data is out there. You can go get this data. But this was one of the neatest research projects. Remember I talked about zero energy buildings? Well, it's really easy to do. I could make this hotel zero energy. You go out and you pull the disconnect and there's no energy coming in the building and you're at zero energy, okay? You're not accomplishing anything, but you're at zero energy. So what could you do to consume as little energy as possible in this building or any building? Well, that's what this project did. They went and looked at every piece of equipment, every toaster, every vacuum cleaner, every fan, every motor. What was and if you put them all together, the most efficient one, and then modeled that building, how low could you go? And all that data is now available for publication. So, I'm done. And I'm probably a few minutes over my time. They were waiting. So, we're way over. So, well, I'll be here all day. I think all of us will be here all day, and we can answer questions and stuff. Okay. So, yes.
Thank you very much.